Hey everyone, this is Dr. Meenambika, Associate Professor and Head, Department of Science and Humanities, Shri Shanmugha College of Engineering and Technology, Sangagiri. Today's session we will see the topic matrices, what are the different types of matrices, and a few examples based on it. So in this session, we will be seeing eigenvalues and eigenvectors of a real matrix, properties of eigenvalues and eigenvectors, Cayley-Hamilton theorem, diagonalization of matrices, reduction of quadratic form to canonical form by orthogonal transformation. So first, let us define a matrix. So a matrix is nothing but a rectangular arrangement of m rows and n columns bounded by the square matrix, square brackets or the braces. It is called an m by n matrix, which is written as m cross n. So in general, we write this matrix capital A as A11, A12, etc., A1n, and it goes on AM1, AM2, etc., AMN. So a matrix is nothing but a rectangular arrangement of elements is called as matrices. So here A is a matrix of order m by n. So we can define few things from the given matrix. So it means that it has m rows and n columns. Whenever we define the order of the matrix has m by n, that is m cross n. It means the number of rows is m and number of columns is n. Each of the mn numbers is called an element of the matrix. See here, we call this A11, A12 and A21, A22 is called the element of the matrix. So the matrix A is denoted by Aij in square brackets. The elements Aij may be real or complex numbers. So they are called the elements of the matrix. Coming to the next definition, order of a matrix. The order of a matrix is denoted by the number of its rows and columns. So we define the order of the matrix as m by n, that is m cross n. M denotes the number of rows and n denotes the number of columns. So here in the example of the matrix which is given, here we see the number of rows as 4 rows and 5 columns are there. So the order of the matrix is 4 cross 5. So this means the number of rows is 4 and number of columns is 5. Next we are moving to the definition of a row matrix. So a matrix having a single row is called a row matrix. That's all. The definition is very simple. Whenever the matrix has a single row, it is called a row matrix. So an example is given, m is equal to 45 minus 8. Only one single row is given. A square matrix. That is, a square matrix means the number of rows and number of columns will be equal. Then only it is called as a square matrix. So here this is a 3 by 3 matrix where it has 3 rows and 3 columns. Next, coming to the definition of null or zero matrix. If we say a matrix to be a zero matrix, if all the elements are 0. So when all the elements become 0, it is called as a zero matrix. For example, here which is given at the last is a 3 by 3 null matrix. This is actually 3 by 2 null matrix. Next we are moving to diagonal matrix. In a square matrix, if all the elements except elements in the main diagonals are 0, then the matrix is called a diagonal matrix. So what it means is only the elements will be present only in the diagonals. Other than that, all other elements will be equal to 0. Next definition is scalar matrix. A scalar matrix is one in which the elements of the leading diagonal are equal and all other elements will be 0. So all the elements that are present in the diagonal will be the same elements, other than all of the elements will be 0. So if this type of matrix occurs, it is called as a scalar matrix. Next, unit matrix or identity matrix. The unit matrix or identity matrix is nothing but when all the diagonal element becomes 1 and all other elements become 0, it is called as unit matrix or identity matrix. Now the order of this matrix is 4 cross 4, where it has 4 rows and 4 columns. Upper triangular matrix. A square matrix. An upper triangular matrix should be first, it should satisfy the condition of a square matrix. A square matrix in which all the elements below the leading diagonal are zeros. So you could see the leading diagonal here as 1, 2, 8, 9 are the leading diagonal elements of this given matrix. So all the elements below the leading diagonal, it has to become 0. So this type of matrix is called upper triangular matrix. So it means the value will be present only in the upper triangle. So all the lower triangle will become 0. Next, lower triangular matrix. So a square matrix in which all the elements above the leading diagonal are 0 is called lower triangular matrix. So the example is given. So the diagonal elements are 1 to 1. So above the diagonal, all elements become 0. This is called as lower triangular matrix. Next, we will define transpose of a matrix. The matrix got from any given matrix A by interchanging its rows and columns is called the transpose of the matrix A. That is, when a matrix A is defined, it is not necessary that it has to be a square matrix. When a matrix is defined, if I am able to rearrange the rows as columns and columns as rows, it becomes the transpose of the matrix. See, for the example, A matrix is given as 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3 appears in the first row. So that first row has to become as first column 1, 2, 3. 4, 5, 6 appears as second row. That has to come as second column 4, 5, 6. 7, 8, 9 appears in third row. So that has to appear in 7, 8, 9 in third column. So this is called as transpose of the matrix. Similarly, another example I have given. You can please go through it. Next comes the definition of symmetric matrix. A square matrix is said to be symmetric when A equal to A transpose. That is, if I am able to transpose, that is, if I am able to rearrange the given matrix by interchanging its rows and columns, even if I get the same matrix A, it is called as symmetric matrix. That is, in short, I can say a matrix A is symmetric if A equal to A transpose. See, for example, I have given the matrix. When you observe the matrix A, 9, 2, 3 appears in the first row. I have to transpose it. That is, I have to make that first row as first column. 9, 2, 3 again the same one. So when I interchange the rows and columns, if the matrix is unaltered, it is called as symmetric matrix. Next is skew symmetric matrix. So just a small difference between symmetric and skew symmetric. A matrix A is symmetric if A equal to minus A transpose. That is, if I am able to interchange and write the rows and columns, and if I am able to put minus, one minus will be coming. Multiplied by minus, it is called as skew symmetric matrix. So in short, skew symmetric matrix is defined as A equal to minus A transpose. Next one is singular matrix. A square matrix A is said to be singular if the determinant value of A is 0. If the determinant value of A is 0, then A is called a singular matrix. If determinant of A not equal to 0, then A is said to be a non-singular matrix. Inverse of a matrix. So as we all know that inverse of a matrix is nothing but 1 by determinant of A into adjoint of A. So from this, if I want to find out adjoint of A inverse into determinant of A is adjoint of A. This is how we find out the inverse of a matrix. So the inverse of the matrix, the formula is A inverse equal to 1 by determinant of A into adjoint of A. Next comes the equality of matrices. When do we say the two matrices to be equal? So the first condition is they should be of the same order and each element of A is equal to the corresponding element of B. So we say the two matrices are of equal, we say they are the same. So when do we say means it should be of same order and each element of A is equal to the corresponding element of B. So example, I have given the matrices. You can just observe. A matrix is 4, 13, minus 2, 19 and B is the same 413 minus 219. So I can say A and B, it is of same order 2 by 2 matrix and all the elements are same. So we can define A equal to B. But when you check A with C, A matrix with C matrix, the first row appears to be the same 413, but the second row is the numbers are not the same, that is the elements are not the same. So A is not equal to C. Similarly, when I observe A and M, just for the comparison purpose I have given, when I observe A and M, 413 it is of 2 by 2, whereas M matrix is of 3 by 2. So it is also not equal. Addition and subtraction of matrices. So if A and B be two matrices of the same order, then their sum A plus B is defined as the matrix in which the sum of the corresponding elements of A and B should be added. See the first example, 4837 plus 1052. The corresponding element 4 plus 1, 8 plus 0, 3 plus 5, 7 plus 2. The corresponding elements has to be added. The same thing goes for subtraction of matrices as well. Multiplication of matrices by a scalar. The product of a matrix A by a scalar K. That is any matrix when it has to be multiplied by a scalar, each element has to be multiplied by the scalar. So that is what the definition says. So multiplication of a matrix by a scalar. So example, if you take A equal to 3 by 7, 3, 7, 9, 10. If I want to multiply it with a scalar 2. So 2 times A. So that means I have to multiply each element of the matrix A by 2. So it will be 2 into 3, 2 into 7, 2 into 9, 2 into 10. So the resultant matrix will be 6, 14, 18, 20. This is multiplication of a matrix. Next, multiplication of two matrices. We will see multiplication of two matrices. So two matrices can be multiplied only when the number of columns in the first is equal to the number of rows in the second. So this is the only condition for multiplication of matrices. So just I want to multiply it 1 into 10 plus 2 into 20 plus 3 into 30, 1 into 11, 2 into 21, 3 into 31. Similarly, second row 4 into 10, 5 into 20, 6 into 30, 4 into 11, 5 into 21, 6 into 31. So when I just simplify this, I get the multiplication of matrices as 140, 146, 320, 335. So with this, I will stop with just introduction about matrices. We will catch you in the next class.